5.8, chords. We've already discussed chords. We know what they are. We've even discussed some properties of them. We're going to just go deeper into their study. All right, so congruent chords and arcs. And we've already had this concept. Whoops. It's not working. Try it again. In the same circle, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, so we already had this slide in an earlier lesson. 5 and 5 are the same. Therefore, this arc length and this arc length are the same. And over here, since we have the same arc measure, right here at 87 degrees, we know that these two chords are congruent. All right, so for examples, you have marked here congruent. Therefore, these two are congruent. So we just set them equal to each other. That's it. I'm going to subtract 2x, get 1x over here. I'm going to add 7 and get 8. X equals 8. But we're not finished because it says find AB, which means we need to plug 8 in right there. 2 times 8 plus 1. So AB is 17. And if you plug it into this one right here, you get 3 times 8, which is 24, minus 7 is 17. Okay, example 2. We have, let's go to a different color here. We have these two chords marked congruent. Therefore, these two arcs are congruent. So we set them equal to each other. 3x plus 36 equals 9x minus 18. That's a 9. There we go. So I'm going to subtract 3x to get 6x over here. I'm going to add 18 and get 54. Yep, 54. And I'm going to divide by 6. X is 9. 9 times 6 is 54. But again, we're finding xw. So we're plugging this 9 in right here. 3 times 9 plus 36. Okay? 9 times 3 is 27. And 27 plus 36 is 63. So xw, the arc, is 63 degrees. Diameter of a chord. If a diameter, or for that matter a radius, of a circle is perpendicular to a chord, then it bisects the chord and its arc. Okay? So we have our diameter here. Looks kind of like a Pokemon ball, doesn't it? Okay, we have our diameter, and we have a chord coming through at 90 degrees. So notice how the chord is marked with hash marks, and so are the two arcs that have been cut. Well, the one arc has been cut into two equal arcs. So, for example, OS. Well, it looks like QS, but yeah, it is QS. So let's go and change this to QS. Oh, sorry, silly me. That's circle S. It's just a big circle symbol. Okay, in circle S, TR is 6. So this piece right here is 6. PR is 98. So this whole thing is 98 degrees. Find the missing pieces. Well, I put the hash mark because since we have a 90-degree angle right here, that the chord OS is perpendicular. I'm sorry, radius. I'm going to write that out. Radius, please write this down. OS is perpendicular to chord PR. Remember we said on the previous slide, it can be a diameter or a radius. So since those two are perpendicular, we know that these two are the same. So PT is also going to be 6. Okay, let's put a line segment over that. Line segment PT is also 6. PQ, which is this part right here. So we know PQ and QR are going to be equal. They've been bisected. Okay, so 98 divided by 2 is 49 degrees. And therefore QR is also going to be 49 degrees. Now PR, line segment PR, is going to be 6 plus 6, which is 12. Nothing to it. Okay, find TV. All right? Well, TV is the length of the chord. Okay, so we haven't used our old friend Pythagoras in a while. So let's look at this. That's 5, and that part's 6, which makes the radius 11. So any radius I draw is going to be 11. But if we connect R and T, look what we have. We have a triangle. Okay? And in this triangle, we have 6 here, and this radius is 11. So we can find this with our good friend Pythagoras. So 6 squared plus b squared equals 11 squared. Right? Now, 6 squared is 36. 11 squared is 121. If we take 121 minus 36, we get 85. So b squared is 85. If we take the square root of that, we get about 9.2. Okay? 9.2 right here. That's this piece right here. But remember, it's also this piece right here because it is bisected by the radius. The chord is bisected. So TV is 18.4 units. All right, new concept. Two chords are congruent if and only if they are equidistant from the center. Same distance. Okay? So AB is congruent because they're both the same distance from the center. And it works the other way also. So if I had this chord, and I knew those were the same, and I had this situation, since I know the chords are the same, then I also know that these are the same. So it goes both directions. So let's apply that. WX and XY are equal. So this chord and this chord are equal. Now remember, that's WX, not WB and CY. It's the whole thing. Right? And they're both 22. Right? So that's 22 and this is 22. Well, notice, therefore, they are the same distance from the center. So that's going the opposite direction. We know this time the chords are the same, so the distances from the center are the same. Therefore, 5x equals 3x plus 4. Now subtract 3x and get 2x equals 4. X is equal to 2. Find AB. Well, I want to plug this 2 in right there. AB is 10. 5 times 2. Okay, now we're almost finished. when two chords intersect inside a circle, then the product times, right, of the segments of one chord equals the product of the segments of the other chord. So part times part equals part times part. In other words, A times B is equal to C times D. Okay? So the product of the segments of one chord. So this is the segment of this chord, CD, the segments of that chord. Therefore, you have A times B equals C times D. So let's apply that. And if it helps, you can do this. So 10 times 5 equals 2x times 16. So that's 50 equals 32x. And if you divide by 32, you get x equals 1.56. Or you can put 1.6. Okay? Again, 3x equals 2 times 12, which is 24. Divide by 3, x is 8. Okay, last one. 5 times 20 is 100 equals 2x squared. Divide by 2, we get x squared equals 50. Okay? So we take square root of both sides. This breaks down to 25 and 2. Radicals, obviously. So x equals square root of 25 is 5, radical 2. Very easy to simplify that one. Okay, last one. This up here is just marking, this right here is just showing you that this chord right here is 8. Okay? So what we have here is 3 times 4, which is 12. And I'm going to come up here, and if I have this is 8, and this is x. Okay, let's just think about what this means. If x was 2, then this portion would be 6. Right? If x was 3, this would be 5. So this over here is 8 minus whatever's over here. Right? 8 minus 2 is 6. 8 minus 3 is 5. And 8 minus x is 8 minus x. So this portion right here is 8 minus x. And we're going to multiply those two segments of the chord. X times 8 minus x. So that gives me 12 equals 8x minus x squared. So I'm going to move my x squared over. I'm going to move my 8x over and leave the 12. And now I have a nice simple factoring problem. I need two numbers. That's supposed to be plus 12, not equals 12. I need two numbers that multiply to give me 12 that add up to 8. Well, that's going to be 6 times 2. And since this is negative 8, they both need to be negative. So my answer is x equals 6 and x equals 2. And that's it.